Okay, so now we're going to continue on, and I want to point out one more thing when we're talking about negative exponents. So I want to jump to example B, but I want to jump to letter C within example B. So for A and B, you've done those throughout this lesson so far, so you should go ahead and you should just quickly be like, all right, well, A to the negative fourth would be 1 over A, and it would become a positive reciprocal. X to the negative, or 8 to the negative third would be 1 over 8 to the third, and you could put that part right there into Desmos if you really wanted to simplify it, and you would see that 8 to the third, let me calculate that real quick, so 8 times 8 times 8 is also written as, or is an equivalent expression, written as 1 over 512. Okay, so now let's look at this here. So I currently have a fraction, but my same rule applies. If I have a negative exponent, I write that fraction as the reciprocal. So here I flip it. So it becomes 3 to the positive 2 over 1. So even though it's already a fraction, I go ahead and write it as its reciprocal. And I write it like that. Now this one here, when I take a number, so 3 squared is 9. 9 divided by 1 is still 9. So I don't have to write that 1. So I could just write it as 3 squared in its simplest form. So 1 over 3 to the power of negative 2 can be simplified just as 3 to the power of 2. So let's go ahead and add that. Let's go back to our notes, and we're going to add another example. So our notes say a negative exponent becomes positive when written as the reciprocal. And originally, every one that we had talked about made it so that it was like a negative exponent here written as a fraction. But now I want to add another example. So this is example number 2. And this time I want to look at it as a current fraction. So here, that's our fraction. So if we write it as its reciprocal or as its inverse, either term is okay. It becomes a to the power of 4 over 1. Those are equivalent expressions. I've made it a positive exponent by writing it as its reciprocal, and I can simplify that by just saying a to the power of 4. So that would be it in its simplest form. So let's look together at, let me go back in our textbook, let's look together at the try these C. So for letter A, they have the same base. This only works when they have the same base. So I have y to the power of 4 over y to the power of 8, which if I'm using my division rules, I can expand it out and do all that, but if I'm using my division rules, I would have 4 minus 8. Now thinking about my integers, if this is 4 and I'm taking away 8, I end up at negative 4. So I'd have y to the negative 4. And I would need to simplify that by writing it as its reciprocal, which is 1 over y to the positive 4. Same thing here. 12 minus 15 becomes, and if I'm on my number line, if I'm at 12 and I'm taking away 15, I end up at negative 3, because same signs add, different signs subtract. So I have 10 to the power of negative 3, which is equivalent to writing it with a positive exponent as its reciprocal. So that's done there. So now if I look over here, I have a lot going on. I actually have 2 different bases. So in yellow is a base of 4, and then in green is going to be the base of 5. And I can think of them as two separate problems. Or I could separate it all out. So I have 4 to the power of negative 2. So let's just take that first part right there. To make it positive, I'll write it as its reciprocal. So it'd be 1 over 4 squared. I have 4 to the positive third already down there, so I just leave that down there. It's positive, so I don't move it. And then I'm going to go ahead and I'm going to deal with my 5s. I'll do this one in a different color. So I have 5 to the power of 7 up top. So I just leave that up top. It's positive. I don't move it. I don't make it its inverse. But then I have 5 to the negative 2. Negative 2 as its reciprocal would become positive 2. So I just want to summarize here. What I did with my positive numbers, clear this off. What I did with my positive numbers was I just left them the same. What I did with my negative numbers is I wrote them, or my numbers with negative exponents, is I wrote them as the reciprocal. Now I can go ahead and I can just simplify this expression the rest of the way. So again, I can combine numbers with the same base. 5 to 7 plus 2, because I'm multiplying, so I'm finding the product, would be 5 to the power of 9. And that's over 4, 2 plus 3, so that's over 4 to the power of 5. So my simplified, and this is in the simplest form possible, would be 5 to the power of 9 and 4 to the power of 5. That is the simplest version. So right now, I just want you to turn and talk. Which numbers did we write as reciprocal? So just looking at letter C. Don't worry about the other ones, but looking at letter C. Which did we write as reciprocals? Which did we leave? Why? And then how did we use our multiplication with exponents rules to simplify? Talk about those 3 things, and then hit play. All right, last thing I want to talk about on that is I want you to talk about why didn't we simplify it any further? So why did we end with 5 to the 9th over 4 to the 5th? Okay, great. So now I want you to do these, check your understandings, but I want you to complete these in Schoology. Okay, so to complete these, check your understanding. This is under Part B or Part 2, and complete these in Schoology.